Okay, in today's video we're going to be looking at what's known as the vector product. Okay, it's part of the vectors topic in the advanced higher. So the vector product is denoted by A cross B. Okay, so that times notation which has been used the multiplication symbol, we read it as A cross B. So it's got many important properties. Okay, there's a lot of properties that are really important here. So again, pause the video, make sure you write it down, make sure you understand them. Okay, but the first thing is on your formula sheet, you'll see that A cross B, the size of it would be the magnitude of A times magnitude of B multiplying sine theta, where theta is the angle between the two vectors A and B. Okay, we'll come to that in the fourth note as well. A times B, the answer to A cross B, is a vector that would be perpendicular to both A and B, and that'll be very important moving forward into other parts of the vector topic. As we noticed from the scalar triple product, okay, if we do A cross B and get the answer 0, then either two things have happened. Either A and B are parallel to each other, or A and B is 0, okay? And the reason why we say we know A is parallel to B is because A cross B is to do with sine of the angle, and if there are two parallel vectors, there would be no angle difference, therefore theta would be 0, sine of 0 would be 0, that's why you get a 0 there as well, okay? So, important thing to know, we're going to see that with one examples, is the magnitude of A cross B, so the answer that we get as a vector, if we take the magnitude of it, would be the area of the parallelogram with the sides determined by the lengths of A and B, as you can see in this diagram here. Okay, and you can see where theta comes into play to get the angle there, but that would span a parallelogram, and the magnitude would get us the area for that. Okay, a few other notes there that I'm just going to let you read through. They're more just properties, okay, that we can use throughout the course. But I'll let you pause the video and you can write them down. But we're going to look at a few examples just now. Okay, first example. Okay, so a vector product can be calculated using the same method as that for the determinant of a 3x3 matrix, okay, which you can see in your formula sheet. So we'll look at example 1. If A equals the vector I plus 2j plus 3k, and B equals 2i minus j plus k, let's find A cross B. Okay, so that's what we're going to do first here. So the first step in the solution, okay, you can pause the video, you can write this down and carry on. We're going to construct a 3x3 matrix. You're literally just taking this off of your formula sheet here. So A cross B, we're going to have our components I, j, and k. Okay, we're then going to put the A vector, so that's going to be 1 lot of I, 2 lots of j, 3 lots of k. Then we're going to put the B vector, which is going to be 2 minus 1 and 1. Okay, just like you practiced before with the scalar triple product. Okay, then we just evaluate the determinant. So it's going to be I with the 2 by 2 determinant of 2, 3, negative 1, 1. Then we're going to change the sign of j. So it's minus j, multiplying, and it will be the determinant of 1, 3, 2, 1. Plus k. Vector, multiplying the determinant of 1, 2, 2, negative 1. Okay, so you should have done matrices by now in the course, therefore you should know how to work this out. So I'm just going to do that. If you need to look back at the previous video on matrices, do so. But we get the values coming out to be 5 times in the I. We then get negative 5 in there, which means that my sign's going to change to positive 5, which I in there. And then we're going to get, with the k, negative 5. Okay, so that's the values that we would get from each of those 2 by 2 determinants there. Okay, remember just changing the sign of the middle one because it was negative j there. Okay, so that's us answered the question. What we found is a vector that would actually be perpendicular to both A and B. Okay, so that's the first one done. We're now going to look at a second and a third example. Now, in the notes, there's actually 4 examples, so I'm going to miss the second one out. I'm going to jump to the third one because that's going to talk about a parallelogram, so we'll have a look at that just now. Okay, so I'll give you time to write that down. But what we're going to do is we're going to find the area of the triangle with vertices, as you can see, A, B and C written there. Okay, so that would actually be the question. And my solution starts underneath this line here. Okay. So part of the note that we wrote down at the start is that if we take the cross product and we work out the magnitude of it, it gets us the area of a parallelogram. Now we only want a triangle, therefore we are going to half that parallelogram. Okay, we're going to half the size that would get us the size of the area of a triangle. Okay, so what we need to do though is we need to actually create the vectors that take us. Remember, these are just coordinates A, B, and C. We actually need to create the lines and the distances to create the original parallelogram. Okay, so we can do this, and I've just picked my point C to be the sort of central point here. So I'm going to work out the vector that takes me from C to A. That'll get me one direction. I'm then going to get me the vector that takes me from C to B, going in the other direction, and therefore I can use those two vectors to do the cross product with, and then get the size of that to get the magnitude of the area of the parallelogram, then half my answer. Okay, so that's what we're going to do. So the first thing I need to do is actually work out what my vector C to A would be. How would I get from C to A? Okay, so if you from higher, in this case it would be the A vector minus the, not the B vector, let me try that again. Minus my C vector. Okay, my A vector would be 1, 3, negative 2. We're going to subtract 2, 1, 1. And that would give me the answer negative 1 to negative 3. Okay, so I found my vector that takes me from C to A. Okay, I'm then going to go and work out what C to B is. So that'll be B minus C. So B would be 4, 3, 0. And C would be 2, 1, 1. And that should give me an answer of 2 to negative 1. Okay, so I've worked out my two vectors that are going to be the vectors that take me along the edges of my shape here. Okay, starting from the point C. So, we want the cross product. Between the two vectors that we've just found. So I, J, and K. Okay, so C to A vector, that was negative 1 to negative 3. That's 2 to negative 1. So again, we're going to work out 2 by 2 determinants. So it'll be the I vector with 2, negative 3, 2, negative 1. Now I've made the same mistake that I just avoided earlier on. Change the sign of the J. And that's going to be negative 1, negative 3, 2, and negative 1. And then K with the last 2 by 2, which would be negative 1, 2, 2, and 2. Okay. So we've got that there. Again, working out each 2 by 2 determinant, we're going to get 4 lots of I at the start. We're then going to get 7 lots inside here, but that's going to be negative 7 now, so negative 7 J. And then the K value would be negative 6K. So the negative 6 inside that 2 by 2 determinant. So I found my vector that's a cross between CA to CB, but I want to get the area here eventually, so I need to get the area of the parallelogram, which would be the size of it. Okay, so the magnitude of CA cross CB, that's going to be the square root. We're going to square all the sizes, so it'll be 4 squared plus negative 7 squared plus negative 6 all squared, square rooted. And it comes out to be the square root of 101. Okay, that's what you would get if you do that. Okay, I'm just going to leave that as a third. Okay, so therefore, that's the area of the parallelogram, area of triangle, means that we half our answer, so it's a half of the square root of 101. Okay, and because it's area, we can then write units squared to finish that off. Okay, so that's using the cross product, the vector product, I should say, to answer a more contextualised question. Okay, we'll look at one last equation, okay, about the fact that we talk about perpendiculars and something else that happens at higher we want unit vectors too. So, final example in the video, we want to find the unit vector that would be perpendicular to both A and B in this case. Okay, so this is the last example we'll look at. Okay, so we want to find the unit vector here. So again, you can pause the video to write this down. But let's look about the solution. So, I need to find a perpendicular vector to start with, which means I'm working out the cross product between the vectors A and B. So I'm going to work out what A cross B is. Okay, so that's going to be 2, 1, negative 1, that's for my A vector, 1, negative 1, and 2 for my B vector there. Okay, and again, we've done this a few times now. We'll write down the 2 by 2 determinants for each one, so 1, negative 1, negative 1, 2. Change the sign of the J, 2, negative 1, 2, and then plus K, which will be 2, 1, 1, negative 1. Okay, so again, doing that, working through them, you should end up being able to get the values here. So it's going to be 1 for the first determinant, so it's just going to be the value I. I'm going to get positive 5 inside my second determinant, but remember it's negative dry, so it'll be negative 5 lots of dry there. And in the last one, I'm going to get negative 3, so it'll be negative 3k. In there. Okay, so I've found my perpendicular vector. Finding the cross product of A and B, I've got my vector here. That is the vector that is perpendicular to both. But we need to find a unit vector for this. Okay, so first of all, this would not be a unit vector. You can probably see with the numbers we've got, it shouldn't be that. We need to find a unit vector for this. So what we'll do is work out the magnitude of what A cross B is to start with. So 1 squared plus negative 5 squared plus negative 3 all squared. So if you square each of these and add them up, you get the square root of 35. Okay. Therefore, if I want to find a unit vector so that it's got a magnitude of size 1, therefore, a way to notate it is you can put it as U with A cross B as a sweet subscript. Okay, we're finding a unit vector for A cross B, and therefore we would just want to have 1 over the square root of 35 multiplying my vector I minus 5j minus 3k, and that would get me a unit vector at that point. Okay, so there's a worksheet accompanying this. Work through the questions, okay, but obviously go back to the video at any points if you need to go through it. Okay.